Hello, it's Callan, JB Racing. Today we're doing a flywheel for a Porsche. So that fits a early 911 and a 914. These flywheels were done on our old Mazak, and we're moving it to this new Haas machine. So we have to do totally new programs. We have to prove everything out again. This is our one done on the other machine, and we're going to be doing this particular one on this machine today. First, we're going to run through the programming side of running this flywheel. We have 4 programs set up already. This is our part, our Porsche flywheel. This gray piece here in the middle is the clamp hold down that holds all that, so we just have to make sure we're clear and not run into it. So the first program we're going to run is all the drilling and the tapping of the clutch bolt holes. So you can see there's quite a bit of stuff that happens. We've got center holes, friction surface holes, clutch holes, ring gear holes out here. The next program is all of the chamfering that deburr all those holes. Those same holes, we're going to deburr all the holes, including inside the middle here. This tool that's in the middle is a 1/2 inch hole, and this is a 5/8 hole. So there's not a lot of room. You can see in the bottom, it's just a small little circle that it's moving, but it does get chamfered in there. Next program is we're putting our part numbers and logos on that. There's a lot of little details in some of these logos, so it takes a little while. I think this program is quite long. Part numbers, and then our final program, which won't show all the way up, is a date code that goes on here. I actually put a date code in this spot over here. Which is why this clamp is cut back. All right, well, let's head over to the machine and start running this. This particular one was done on the old Mazak. Not much to see difference here. The difference between this part and the part we're currently doing is this is a 140 millimeter clutch. It has lightning holes in it because there's more room to do that. The one we're doing now is a 184 millimeter clutch. There isn't room for any lightning holes. It's already way lighter than the stock clutch, the stock flywheel. These have been turned on the Mazak lathe already, ready to get drilled. This particular flywheel is for early 911s and 914s. There's a couple versions we offer for those particular cars, depending on transmissions. This particular one, I don't remember exactly which engine package it is, but it's early 911, 914. So what we're gonna do first is we're gonna prove this program out. We have 4 programs we're gonna run. Drilling programs, deburring programs, engraving program, and then a date code program. So first off, we're gonna put this in the machine. Here's our Porsche flywheel fixture. We made these fixtures specifically for the Porsche flywheels. So we'll go ahead and it has a roll pin in it to clock the nut, to clock the clamp washer, which has to be clocked because we're going to be putting a date code over here on the side. So it has a roll pin to kind of help clock it in place. All right, program number 1. All right, we're gonna check this, make sure this clamp, 157. Just wanna make sure the clamp is in the right spot for the holes and centered on the holes. So we're just going to call up the drill, and then we'll run the drill down by hand into the hole. Okay, right there. Blow this thing off real quick. We'll jog this thing down in the hole. Just want to make sure that the drill is in the middle of the hole. Looks pretty good. Middle of the clamp hole. Would be a bit of a problem if it wasn't. Okay, looks pretty good. Drill back out of the way. All right, now we can run the first program. Run this kind of slow, just slow rapids, and just in case something pops up, I can stop it. This is a first run of this program. All right, drilling holes. Sounds good, looks good. I don't know if you can see me, but I have my finger is on the feed hole button. Just in case there's something I don't like, all I gotta do is just push the button and pause. This is a pretty deep flywheel, so it holds lots of coolant. So it's pretty blind as an operator. I just hope and pray you don't hear any loud, weird noises. Once it starts getting more holes in it, it'll kind of run, it'll kind of start emptying itself a little bit more, but it'll still be pretty blind in there. Now we're tapping holes, friction surface holes. Once we know that this program is all good, we'll actually turn on some other features. Every time it does a tool change, it'll go to that little table probe that's back there in the black box and check and make sure the tool is not broken before it goes to the next tool. So we can run a little more automated at that point where if it has an issue, it will stop and you don't have to stand here with your finger on the button all day long watching all this happen. If it does break something or something moves, like say that drill moves inside the holder and it sees it, it'll do that before it runs the tap in there and breaks the tap off. Adds a little bit of time, you know, a minute or so for the part, but in the end it's nice to know that something's going to catch it if you don't catch it. And we're going to tap clutch mounting holes. As soon as that program, I'm just going to blow it off and we'll look at it here in a second, see how it looks. This tool that's running now is a spring-loaded fan. So every program we run through here, the last tool is this fan. It just blows off the table and it saves a lot of time with the air gun blowing off everything. It won't get everything off the table, but it gets about 90% of it off, and it's emptied that Porsche clutch, the Porsche flywheel bowl. It's pretty well empty now. So a little bit more blowing. Let's look at the hole. Okay, we've got threads in the holes. We're supposed to have threads in. All the big holes go all the way through. Everything goes all the way through the bottom like we expect. These big holes have holes all the way through. Outer holes look good. Okay, well, it has holes and it has threads where it's supposed to have threads. They look good, they look clean. We can, time for the next program. We'll keep it just like that. We'll run the next one. All right, the next one's going to do chamfering all the holes, and the threaded holes, the non-threaded holes, the big hole. So this is a scary one here because it goes down, takes a 1/2-inch chamfer, and goes down inside a 5/8 hole. Not a lot of clearance. And there it goes. No scary noises, no loud bangs. Other thing I'm looking for is when the tool comes out of the hole, the side of the chamfer is still shiny. The piece of carbide is shiny and doesn't have a bunch of white scrapes on it. That would be from hitting the side of the hole and the aluminum. It'll smear on there like that. Chamfer and friction surface holes. Chamfers on all the threaded holes, we do 30 thou chamfer. I found that it's really nice, but 20 is nice, it looks good, but it's still kind of hard to get a screw started, so 30 makes it nice and clean, and you notice no burr at the start of the threads. It just screw, bolt, whatever's going in the hole just goes in nice and clean, and it looks nice. Big chamfer. I'm going to switch to the small chamfer and do the outside holes for the ring gear. Blow it back off. When it's a full running program for a part, the fan only comes out one time at the very end. So this is a little different because we're running multiple programs, so the fan's coming out multiple times. So far we've got holes drilled and tapped, and we've got holes are chamfered now. We're at about 7 minutes or so, 7.5 minutes to this point. There's a minute for each fan operation, so that's got a minute added in there. All right, let's look at those chamfers. Looks pretty good. Nice and clean. These look good out here. No burrs inside. Let's check some of these big ones at the bottom. Nice clean little chamfer on that hole. You can see this one here's got good chamfer. And down in here I gotta blow some air to keep it away. Looks pretty good in there. Just fills back with coolant because it's all underneath the flywheel right now. Looks good. All this looks good. Little small chamfer there. Okay, all right. Now we'll do the engraving. This one's a little long run. We'll speed this up a little bit. Increase the rapids a little. Okay. Engraving. Here we go. Engraving. All right. Part number looks good. Logo looks good. Looks good. Nice and clean. No burrs. Cool. All right. Last program. The probe in here and then do a date code on here. And that's the scary one. At least for me, because it's really close. Be a finished part now. Got a date code down there, looks clean, feels good. Now we get to take it out. All right, here we are, fresh out of the machine. We got our part number up here, a couple logos, our date code. Everything is chamfered on this side. Looks really good, looks really clean. The back side, we don't quite yet have a fixture. For the BMWs, we have a fixture that we can flip over and put on the back side and do all the deburring in the machine. We don't quite have a fixture for that yet for the Porsches. It's in the works. So we'll have to deburr these holes by hand over here on the toolbox. And then we'll clean all this off and look at it and inspect it. If we did this in the machine, so probably about the same speed as what would be in the machine. It would just be a lot more, it'd be a lot cleaner out here on the table than it is right now with all the shavings that show up. Okay, so I've got clutch bolt. I want to run this in here and make sure this looks good, doesn't feel weird at all, and it's going far enough. And it is. Going right to the end. On the Porsche flywheels, there isn't a lot of room back here to the case, so we really don't want to have any hardware sticking out. It can stick out in the hole, but we don't really want it hanging out of the back of the flywheel. And see on this other one, same kind of thing. So when we size the clutch hardware, the differences in the lengths, we can play with the lengths depending on which clutch pack is on here to get the proper stick out. You know, there is no stick out. That's really the thing. All right, so that looks good. Check another hole. Feels really good. All right, our clutch friction surface. Check a couple of those bolts. Looks pretty good. It's plenty of meat in the inside of this flywheel that have bolt way longer than it needs. That's what this is. It's a longer bolt than I really need. But just to kind of feel and make sure that it is going clean all the way to the bottom. Looks pretty good. The next thing is to put a friction surface in here and just make sure the holes line up with the friction surface. That's kind of important. Looks really good. Throw this in here. Let me get a looks good. Everything's lined up with the friction surface. Sweet. Looks really nice. Feels good. Alright, so these two that are here, kind of see how this is already set up in the, when this is turned in the lathe, we use one of these friction surfaces to kind of gauge the inside of this lip. We really want it to be tight enough to slip in there, but not to move. That way this is really held in the middle of the flywheel, and the bolts just hold it in. And that's what you see there. It's nice. All right. So really the difference between these two flywheels here, I'll position these part number up for you. We've got, the lightning holes are different. You can kind of see the bowl. This is more of a bowl on this one. This is almost more of a vertical wall. So the clutch, this is a bigger clutch, so it needs more room and more kind of walls out here. Smaller clutch here. I believe the offset is the same offset, just different clutches, different horsepower, different transmission packages for each one of these. Same car, just different clutch diameter, and just depends on what class and what you want to run. These are not street friction surfaces, they are race only friction surfaces for the Porsche stuff. You can see this one on the engraving on this part, it's a much shinier engraver. The coolant we're using in this machine just is much happier than the old coolant and the old tooling. It's working really good. This looks good. Same thing they had to do on this one. They have to deburr all this by hand because we don't have a fixture yet. But we will. Once we have a fixture, it comes out of the machine. All the holes that are tapped and drilled, all that will have the same look on this side and the same as this side. They'll be the same. All this will be good. And we won't have to do any hand processing, which is nice. We just come out of the machine, blow it off, wipe it down, inspect, put it in the rack. So that looks pretty good. That's the first good run of this part. Now we're gonna start running these through the machine, and we'll get these ready to go. We'll stick this in the rack. See you in the next one.